some numericals on Lensmeter formula and lens formula. Here is the question: a convex lens made of a glass of refractive index 1.5 is dipped in term. A medium of refractive index 1.65 and a medium of refractive index 1.33. Question is, will it behave as a converging lens or diverging lens? And second, how will its focal length change in two media? Okay, simple. Now we have Lensmeter formula. It was 1 upon f equal to mu L, that means medium of lens, upon mu m, refractive index of medium, minus 1 into 1 minus R1 minus 1 upon R2. Okay. Now see the situation. This term 1 upon R1 and 1 upon R2 is decided by the construction, because these are the radius of curvature. So because of change in medium, this term will not change. It's for sure. Okay. See here, this is medium of lens and it is given 1.5, and this is mu m, medium in which lens is immersed or dipped. Okay. And this is f. F, we know that focal length, it is positive for convex lens. Okay. It is positive for convex lens, and that is called converging lens. Another name is converging lens. It will be positive and it will be negative for concave lens or diverging lens. Okay. Now see the term here. This term is fixed and here is mu L upon mu n. If this ratio mu L upon mu n is greater than 1, then this whole term will be positive, and so f will be positive and it will behave as a convex lens. If this ratio mu L upon mu m is less than 1, then this is less than 1 and this is 1. This term becomes negative. This term becomes negative, and so f becomes diverging lens or concave lens. Okay. Now see the first case. In first case, it will be 1 upon, let us say f1, mu L is 1.5 and refractive index of medium is 1.65. 1.65 minus 1 and 1 upon R1 minus 1 upon R2. See here, this ratio is less than 1 because 1.5 is less than 1.65. So this term will be negative. So in this case, lens will be concave. Concave means diverging lens. Okay. In second case, the refractive index is 1.33. In this case, the medium of lens is 1.5 and refractive index of medium is 1.33 minus 1 and it is 1 upon R1 minus 1 upon R2. Now this ratio 1.5 upon 1.1 is greater than 1. So f2 will be positive. So lens will be convex or converging lens. Okay, simple question. In second part, how will its focal length change in two media? Okay, let's divide it. If I divide it, what will happen? it will be F2 upon F1 will be 1.65 minus 1 upon 1.5 minus 1.33 minus 1. Now, after solving this, we will get this value as 4. So, we can say that F2 will be 4 times F1. Okay. In second time, when refractive index becomes 1.33, then focal length becomes 4 times compared to first case. Okay. Another question on lens formula, Lensmeter formula. Okay. Here is the question: the radii of curvature of faces of a double convex lens are 10 centimeter and 15 centimeter. Okay. If focal length of lens is 12 centimeter, find the refractive index of material used. And we know that we have formula 1 upon F equal to mu L upon mu M minus 1 upon R1 minus 1 upon R2. Here second medium, that is medium, refractive index of medium is not mentioned. So by default we will take it as a air and mu M will be 1. Okay. Now given focal length is given, it is 12 centimeter. R1 is given, it is 10 centimeter. And lens is like this. If R1, this is R1 and this is R2, it will be positive and it will be negative because of it is in the left side. So R2 will be minus of 15 centimeter. Okay. Now apply the formula 1 upon F, that means 1 upon 12, and refractive index is not known to you, that means it will be mu L minus 1 and it will be 1 upon 10 and minus 1 upon 15. Okay, it becomes positive. It will be 1 upon 12 mu L minus 1 and it will be 30 and it is 3 plus 2. Okay, and it is 1 upon 12 mu L minus 1 equal to 5 upon 30, 5 6 and 6 2 ja. Okay, that is 1 upon 2 equal to mu L minus 1. So mu L will be 1 by 2 plus 1, it will be 3 by 2. Simple question and simple solution. Okay, thank you. Here is a next question. Question is: a biconvex lens has a focal length 2 by 3 times the radius of curvature of either surface. Calculate the refractive index of lens. Very easy question. It is a biconvex lens. That means the radius of curvature will be same. That is, magnitude of R1 must be equal to magnitude of R2, and let us say it R. Okay. Also given focal length is 2 by 3 times. That means F is 2 by 3 times R. That means R upon F must be 3 by 2. Okay. Now we have formula, Lensmeter formula, 1 upon F equal to mu L upon mu M minus 1 and 1 upon R minus 1 upon minus R. Okay, 1 upon F, and because medium is not mentioned here, by default we will take mu M as air. It will be mu L minus 1 and it becomes 2 upon R. Okay, Now take R in left side. It will be R upon 2F equal to mu L minus 1. Okay, and R upon F equal to 3 by 2. That means 3 by 2 into 2 equal to mu L minus 1. So mu L will be equal to 3 by 4 plus 1. It will be 7 by 4. Simple question, simple solution. Thank you. Here is next question. Find the radius of curvature of convex surface of a plano-convex lens. What do you mean by plano-convex? That means one surface is plane and second surface is convex. Okay, whose focal length is 0.3 meter. That means F is given 0.3 meter. And as we know that the plane surface have radius of curvature infinite. Okay, and let it be R. It is unknown. Okay, and material of the lens is, that means mu L is 1.5. Just put the value. We have the lens formula 1 upon F equal to mu L mu M minus 1 upon R1 minus 1 upon R2. Okay. Focal length is given 0.3 meter. That means 1 upon 0.3. And mu L is 1.5. And because medium is not mentioned, by default we take it as a air. And 1 upon R. R is 1 upon infinity. And minus, it will be minus of R. Okay, let's remove the decimal. It is 10 by 3 and it will be 1.5 minus 1.5, that is 1 by 2, and 1 upon infinity 0, and it becomes 1 upon R. So 1 upon R will be 20 by 3, 10 by 3, and this is 1 by 2, 1 upon R. So it will be 20 by 1 upon R equal to 20 by 3. So R will be 3 by 20 meter. Okay, 3 by 20. A converging lens has focal length of 20 centimeter. Okay, that means F is given 20 centimeter and it is converging, that means convex lens in air. It is made of material of refractive index 1.6. That means mu L is given 1.6. If it is immersed in a liquid of refractive index 1.3, that means mu M is given 1.3. Calculate new focal length. Simple question. Let it is initially F when there is air. So mu L upon mu M minus 1 equal to 1 upon R1 minus 1 upon R2. When there is air, its focal length is 20 centimeter. Okay, we will put in last, let it F1. So F1 equal to mu L. Mu L is 1.6 minus 1 and it is 1 upon R1 minus 1 upon R2. Let it is equation number 1. Now when it is immersed, okay, when it is immersed, okay, then let it be focal length F2 then it becomes 1.6 upon 1.3 minus 1 and 1 upon R1 minus 1 upon R2. Let's solve it. 1 upon F2 will be 1.6 minus 1.3 upon 1.3 into 1 upon R1 minus 1 upon R2. Okay. It comes as 0.3 upon 1.3 into 1 upon R1 minus 1 upon R2, and it will be 1 upon F2. Let's divide. Okay. Let's divide both equations 1 and say it as a 2. 1 upon 2. So it becomes F2 upon F1, F2 upon F1, and equation 1 is here 1.6 minus 1, it will be 0.6. Okay, and here is 1 upon R1 minus 1 upon R2, here is also 1 upon R1, 1 upon R2, it will be cancelled. So here is 0.3 into, it becomes 1.3. We can remove the decimal, it will be 2. So F2 will be, it is 2.6 times F1, and F1 is 20 centimeter. It is 20 centimeter and it is 2.6. So it is 20. So 40 and 12, it becomes 52 centimeter. So the new focal length will be 52 centimeter. Okay, that's simple question.